So as we wrap up on working with the frequency distribution, we want to talk about a graph that's called an ogive. It's also known as the cumulative frequency graph. So an ogive, and I guess this is kind of the pronunciation, it's not ogive, it's actually more of a J sound. An ogive, an ogive is a graph similar to a polygon or line graph. The horizontal scale, though, is going to be represented by the upper boundaries. And the vertical scale will be the cumulative frequency that we found in the expanded frequency table. So the thing though is this line graph needs to begin with the cumulative frequency being 0. So we have to use the first lower boundary to start the graph at 0. So the first lower boundary was actually, if we go back up here, we actually have to use the 64.5 because that's going to be outside of our information. And there wasn't going to be any frequencies in that data. So 64.5, and we're going to have a 0 there. So the 74.5, the 84.5, the 94.5, the 104.5, the 114.5, and the 124.5, those are going to be the upper boundaries. So I put those on my table, but I still need to put the 64.5. So we have to actually drop over one class width, if you will, of that 10 to get back down there. The cumulative frequencies, again, I found those in my expanded table, and for 74.5 was 4, then 11, 15, 20, 23, and 24 were our cumulative frequencies. Remember, cumulative frequency, we just add the frequency, and we keep adding the cumulative frequencies. We kind of add the previous frequency to the new frequency, and we keep getting that. Remember, the catch is, though, the final frequency should be the sum of all frequencies. That should represent all the students in the class. So that should represent the very end of it all. So since I look at this data 0, 4, 11, 15, 20, 23, 24, there's not a whole lot of data, and it seems like counting by fives would be a reasonable scale. I didn't want to count by ones, but counting by fives seemed to be a little bit more reasonable. So 5, 10, 15, 20, 25, and 30, that would be our scale that I'm going to use there. Remember, the horizontal scale is actually broken. We just start out at 64.5. So using that data, at 64.5, the frequency was 0. That's going to put us back on the horizontal scale itself. 74.5 is going to be 4. So 74.5 is going to be 4. So that's going to be a shade lower than 5. So I have to estimate that a little bit. 84.5 is an 11. So out here, I'm getting 11. That's going to be a little bit above 10. So I'm just kind of estimate that best I can. 94.5 is 15. So 94.5 is the 15. 104.5 is the 23. So almost halfway, a little bit over halfway there between 20 and 25. So I'm going to kind of mark it about there. And then the 124 point, that should be the 24. So I'm sorry, no, we're not there yet. 114.5 would be, did I miss something there? Yeah. 74.5 is for 11, 15, 20. I missed my 20, didn't I? Oops. Where's my eraser at? So at 104.5, we should have had a 20. So that'd be here. 114.5 would be 23. So that's going to be a little bit more closer to 25. And then the 124.5 was like 24. So it should be even a little bit closer to 25. So it's kind of climbing like that. So I'm going to pause for a moment. I'm going to try to connect these lines like we did in that polygon we did earlier. So I'm going to pause this for a second and finish this up. So as we go through this, we kind of see that our line graph, our ogive here, would turn into this. So again, this represents all the students. You know, 23 would fall from, all the way back this way. So that's our representative of our data there. So again, with line graphs, you're kind of looking for like this incline. So between 64 and 65, that looks pretty steep. But 74 to 84.5 looks not quite as steep. So as far as steepness goes, this looks like the steepest. The least steepest would probably be between 114 and 124.5. That looks like the flattest line to me if I was looking at data. That's one of the tricks. That's why we start to graph data using technology, because here you can kind of see that my spacing is not quite right between 64.5 and 74.5. And then between 74.5 and 84.5, my spacing is not very accurate. And technology is going to make things a little bit more precise. So that's why a lot of times they want stuff done in Excel. We're going to use our graphing calculator, our TI-84. We're going to use it for a lot of this to kind of generate graphs and things like that, because it is too hard to try to create all these graphs by hand. That's where all the learning goes, though, is if you do stuff by hand, you really grasp the vocabulary a lot quicker. This tactile learning, if you will, by actually creating an Ogive graph, a relative frequency graph, doing all this by hand a couple of times, it will embed your long-term memory where you wouldn't have to necessarily go back to notes. That's where technology, you just crank it out there and you really don't remember all the vocabulary. But by doing this by hand like I did, it's really creating a lot stronger memories for me. So that concludes my lesson on the Ogive, which is kind of what we call a cumulative frequency graph. Again, the vertical scale is the cumulative frequency, and the horizontal scale is the upper boundaries. But remember, it has to start at 0, so we have to make the 64.5 come into play, that one lower limit. So notice how it does in the graph. It does start at 0, but also it finishes at the sum of all values, which is the 24. That 24 is going to be our magic number on the ascend here.